Okay, lesson 17.2, adding polynomial expressions. This is truly a lesson where doing the same thing in different ways, so I'm very quickly going to go through this. The first way to do this is using algebra tiles. You may have seen this before, possibly not, but the small boxes here represent constants. The skinny boxes represent just x terms, one being positive, one being negative. And then the big boxes represent x squared, like a square, positive, negative. So we have an example problem here, 2x squared minus x plus x squared plus 3x minus 1. So the first thing we need to do is model each. So the expression 2x squared minus x is represented with 2x squareds and then a negative x. The second polynomial is represented with an x squared, 3 x's, and then a negative 1. So the idea here is to combine these. So we have our first polynomial plus our second polynomial. It says rearrange the tiles so that you have like tiles together. We refer to them as like terms. So we take all of our x squareds, put those together. We take all of our x terms, put those together, and then our constants. And then basically what happens is anything that we have opposites, in this case a negative x and a positive x, will cancel. So then what are we left with? We are left with 3x squareds. We're left with 2 x's positive, and then we're left with a minus 1. So then another way to add polynomials is to do what's known as the vertical format. So you take the two polynomials, you line them up vertically with like terms combined, and then you just go ahead and add. So you add the coefficients, 5 plus 4 is 9, 2 plus negative 1 is 1, negative 1 plus 2 is positive 1. What you don't do is you do not add the coefficients here. It stays x squared. And this is where the algebra tiles come in handy in terms of explaining, because when you add the algebra tiles, you're just counting up how many tiles you have. So here we have a total of 9 x squareds, square tiles. We have a total of positive 1 x's. So the algebra tiles are useful here in explaining that you do not do anything to the exponents, you just add the coefficients. So real quickly here, I'm going to take one of the your turn problems. I'm going to take problem number 4. I'm going to do it in the vertical format. So I have negative, and you might be helpful here if you put the 1. Now again, that's optional, but it's not bad to do that. This is a positive 2, z to the third, minus, again, you might want to put that. Okay, so there's a vertical format. Now, what I don't have is I don't have an alignment here. So what I need to do is go back and I need to shift over my terms from my 2z and my negative 1. So I'm going to rewrite this. And then here, if you need to, put a 0z squared to fill in the gap so that you have the alignment. And write your second polynomial. So now we have an alignment here with terms. And then if you need to here, put a 0, just so you have everything vertically aligned. So one of the things you can do here is these cancel because they're opposites. So now I have 1z to the third minus 1z to the second minus 1. Or you could just write z to the third minus c squared minus 1. And personally, my preferred format is what is known as the horizontal format. And all I do here is just write out the problem, and then I use underlining to help denote what are like terms. And then I go ahead and combine those, combining just their coefficients. And then I take what's left and put that down. So again, I could take the next example, problem 7. Write the two polynomials down. Then underline any like terms I have. And then I'm going to combine my like terms. Now in this case, I'm going to try to do standard form. So the first thing I have to do is alphabetical order, highest degree to lowest. So x comes before y. My highest degree is x to the third. So I have negative 5 x to the third, because remember, right here we do have a 1. And then I have plus x, and then plus y, and then my constant is always last. Now, in this last example, one of the things I'm going to do a little differently is I'm still going to write this, and then plus 3y plus 18. But one of the things that might be helpful to you is as you combine your like terms, so here I do 2 lines to indicate those are like terms. One of the things you might want to do here is as you add, mark those terms out so you know you've already used those. Now, again, this is all about the same thing in different ways, so you choose what works for you and stick with that. So here we have a word problem example. I'm going to skip example 3a because, again, this is one that's worked out for you. And I'm going to go to the your turn problems. And I'm going to do problem 10 with you here real quickly. A scientist is growing cell cultures and examining the effects of various substances on them as part of his research. The culture in one petri dish increases according to the expression. So here's our expression for the increase for time t in minutes. Another increases according to this expression. He needs to feed all the cells equally, so he needs to know the expression for the total number. So total number just means we add for the both dishes. So all we're doing here is we're adding the two expressions. So again, I like the horizontal method, so I have t squared plus 4t plus 4 plus t squared plus 2t plus 4. So again, I use different numbers of lines, underlining to indicate my like terms. Then I'm going to combine those. And again, remember there's a 1 here. So I have 2t squared. Those are now gone. Plus 6t. These are now gone. Plus 8. And those are now gone. So, relatively simple lesson. Again, just doing the same thing in different ways. And now you can do the homework for lesson 17.2. So the problem numbers for this are on page, first of all, 823, and you're doing numbers 1 through 21 odd, and then number 22.